And I thought it was just fantastic. Anyway, you'll notice that I have a subtitle on here saying into the future and back. And I hope that that becomes apparent when I get to a particular chart in my presentation here. So next chart.
Okay. Yeah,
Maybe. There we go. So this is actually in 3 parts. I may get to parts 2 and 3 if we have time later on. But the first part, I'm going to just cover solar eclipses in general and the total solar eclipse of April the 8th in particular. Okay, here. This is a little bit of trivia on solar eclipses. I found some of this information to be kind of interesting. As I think most people know, we have on Earth the abilities to see solar eclipses or total solar eclipses because even though the sun is 400 times larger than the moon, it's also 400 times farther away. So it balances out so that basically you have the same angular diameter of the sun as you have from the moon from the surface of the Earth. On average, a total solar eclipse is seen from the same place once in 366 years. And there are exceptions to that, and I'll bring that up in just a little bit. From 2 to 5 solar eclipses occur each year, but no more than 2 can be total. And based on 5,000 years of eclipse data, it turns out that May is the most likely month for a total solar eclipse. I have no idea why, but 6 months after that, we have the least likely month, which is November. The greatest possible duration of a total solar eclipse is 7 minutes, 32 seconds. A totally eclipsed sun is about as bright as a full moon. On the surface, you would think that that doesn't make any sense because if you have the sun eclipsed, there shouldn't be any brightness at all. But what happens here is that during a total solar eclipse, we do cover the surface of the sun, but the moon does not cover the corona, which is the atmosphere of the sun. And because the moon is receding from the Earth in about I guess it is about 600 million years from now, we won't have any total solar eclipses at all. Yeah, well, hang on. Okay. Now, this one that we had on April the 8th was called the Great Northern American Eclipse. That should not be confused with the previous total solar eclipse that went across the United States back in 2017. That was called the Great American Eclipse. But these depictions here, these figures, show you the path of totality for both of them. If you notice the one on the left, which is 2017, the path of totality is narrower than the one that we have on the right-hand side. And the reason for that is that it turns out that the eclipse on April the 8th occurred just 2 hours, less than 2 hours, after the moon reached perigee. So that meant that the moon was bigger in the angular diameter, and that as a result, the shadow was wider. Okay, now this is a close-up of the paths of totality. Turns out that the center point of those 2 eclipses, the paths of totality, was centered on Carbondale, Illinois. And so when I say that there are exceptions to the rule, Carbondale is an extreme exception. Carbondale experienced 2 total solar eclipses within 7 years. I think that's amazing. Okay, go ahead. Now, on the left is a mosaic of pictures taken from space from a satellite for August 21st, 2017, which is a great American eclipse. The one on the right is the one that occurred just earlier this month, April the 8th. As you can see, Carbondale had excellent weather for both total solar eclipses. If you wanted to see a nice view of the solar eclipse on each occasion, you should have been at Carbondale, turns out. I have small yellow dots on here. The one on the left is a small, you'll see a second small yellow point, and that's Paducah, Kentucky. That's where I was on, for the eclipse in 2017. The one on the right, up in the upper right-hand corner, that's Wapakoneta, Ohio. That's where I was for the great North American eclipse on April the 8th. Go ahead, Gary. One thing that NASA has done is, actually it's NOAA. They have a satellite called GOES-16. It's in geosynchronous orbit. And what they do, or that satellite does, is it takes pictures every day of the United States for weather purposes. So on both occasions, in 2017 and 2024, when we had the total solar eclipse, they did a mosaic, which is shown here. It's called a time composite of pictures. What they do is they home in on the darkest pixels. And by doing this type of time composition, they can get a very nice, crisp indication of where the paths of totality were in the United States. Okay. Now here's the eclipse on April the 8th by the numbers. I won't go through all of them, but this eclipse on April the 8th was Ceros 139. It turns out that for each total solar eclipse, there's a twin. Now, twin happens after one exo-igmos. What that exo-igmos is 3 Ceres cycles. A Ceres cycle is 18.6 years. So an exo-igmos is something like about, I think it's 54 years, is it? I think it's 54 years. So the twin of this one will happen on May the 11th, 2078. Maximum duration of totality for this one was 4 minutes and 28 seconds. That actually occurred right there in Mexico. Total length of the path of totality was 10,020 miles. Maximum width was 126 miles. Average speed of the shadow over the United States was 1,993 miles per hour. That's just about Mach 3. And the number of people in the United States who live in the path of totality for that eclipse, over 31 million. What they claim is that this total solar eclipse that we saw on April the 8th was the most viewed solar eclipse in history. Go ahead. Oh. And this shows the major cities that were on the path of totality, all the way from Mexico up to Canada. If you add up just those cities that are shown, you have nearly 10 million people just in those cities who live there who could have seen it, assuming that you had clear skies. Go ahead. So what I have here is talking about this shadow speed. I have for each city that I have identified here, I have the shadow speed. And you can see I have also the Mach number listed. That shadow speed went from Mach 2 in Mexico all the way up to more than Mach 6 in Newfoundland. Now, one thing I noticed when I was doing the research here is that there's some scientist, I think he was with NASA, who claimed that at the very beginning of the eclipse and at the very end of the eclipse, the shadow speed exceeded 5 million miles an hour. So I don't know how he came up with that. That's a fantastic number. But anyway, I included that, even though I can't verify it.
Okay. Oops. Wait, I got to get back.
That's okay.
Here.
Now, talking about going into the future, I did this on my own. I think that this figure is very accurate based on my calculations. I show the path of totality along with the date line, international date line. The international date line is that dashed line that's shown in the middle of the figure here. If you notice, the eclipse started right there on the right-hand side of the international date line. That was Monday, April the 8th. Everything to the left of the date line was Tuesday, April the 9th. As you can see, the path of totality went from April the 8th into April the 9th, didn't like April the 9th, and came back to April the 8th. So this eclipse, I don't know if it's unique or not, but this eclipse actually occurred in, it changed dates twice. So I thought that was kind of interesting. Now, another thing that I think was very interesting about this eclipse is that every major body in the solar system was visible during this eclipse. You had the sun and the moon, which were the highlights of the day. You had Mercury, Venus, Mars, Jupiter, Uranus, Neptune, and Saturn all lined up. And I think it would be kind of interesting to find out if anybody in the PVAA saw, more than one of those objects. Okay, now, obviously, you're not going to see the eclipse if you have clouds. What I'm showing here is the mean cloud fraction for April the 8th based on GOES observations for 29 years. You would think that this would be the best information that you could get on trying to predict, trying to find the best place to go 6 months in advance. And as you can see, down in the south, right around Mexico and Texas, you have the least cloud cover for that day. As you go farther and farther north, it gets more and more cloudy. And I think that most people, especially the guys here in the PVAA, I think went to Texas because of this. We'll find out a little bit more about that in just a second. Go ahead, Gary. Now this is the chart. This is an actual prediction of the cloud coverage for April the 1st, or this was actually for April the 8th as predicted on April the 1st. Note what the cloud coverage was going to be like. It was completely reversed. The worst cloud coverage based on this prediction was going to be in Texas, and the best would be up there in the northeastern part of the United States. What you need to keep in mind is the date when this prediction was made, April 1st. Keep that in mind. Go ahead, Karen. Okay, now this is an actual image of North America from the GOES 16 satellite on April the 8th. And as you can see, lo and behold, there must have been some kind of influence from the heavens, because if you look along the path of totality, there's a parting of the clouds. And I thought that was amazing. Oh, yeah, you're right. And that's it. Okay.
Okay.
So that's my lead in. There you go.
Yeah.
Starting right there.
All right.
Okay, now part two concentrates on observations from spacecraft, obviously from space. And those observations are basically of not the eclipse, but the shadow of the moon on the Earth's surface. So let's look at the first one here. This is by no means a complete list, but this is at least a partial list of the satellites that are in space that actually participated in getting information on the eclipse on April the 8th. They range from the International Space Station, which is the first one listed, all the way to what is called the Solar Orbiter by the European Space Agency, which is over 100 million miles away. But like I say, most of the observations had to do with the moon shadow. So that's what I'm going to show you here coming up. So first one here is the International Space Station. There are two astronauts on board that were involved in getting the pictures. First one is flight engineer Matthew Dominic. Second one is Jeanette Epps. They photographed and videotaped the moon shadow through the cupola that is on board the space station. And the following picture shows the moon shadow or umbra moving from New York State into Newfoundland. It shows portions of Maine and the Canadian provinces of Quebec and New Brunswick as the space station soared into the moon shadow during the eclipse. So this is it right here. On the left, I think basically everything that you see here is basically in Canada. I was going to say that on the left, you might see parts of Maine, but it's very clear that, you know, you can see where the moon shadow lies from that perspective. I don't think this is the first observation of an eclipse from space, you know, from a manned space station, but it looks like they did a pretty good job getting this. Unfortunately, from what I was able to read, the astronauts on board the space station were, even though they could see the shadow, they could not see the eclipse itself, unfortunately. Next one is from Starlink. I didn't know that Starlink had cameras on board, but they do. So this is a series of photographs that have been put together in the form of a video that obviously shows the moon shadow on the Earth's surface down below and parts of the Starlink satellite up above there. I don't know what was going on that satellite, but you can see there is an antenna or probably solar arrays that are actually moving, apparently moving with the sun, which is kind of neat. Okay, Gary. Next one is from GO-16. Like I said earlier, this is in geosynchronous orbit. And this is a series of photographs that were taken. This one is prior to the eclipse, so this will be in rapid sequence, Gary. So next one, okay, you can see the eclipse coming, or the shadow of the moon in Mexico, now Texas, then up there, probably right around Ohio, then up there in Canada, in the end. So as I said before, what's interesting here is, you look at the path of totality. Path of totality was just, worked out pretty much very well with the clouds. The clouds parted, and most people that went to Texas, I think, like we heard earlier, got to see at least part of the eclipse. And this is a movie taken This is
It's not a sharp shadow because the sun is so big.
this is
The light folds around.
another. I think this is probably GOES 16 also. There's a GOES East, there's a GOES West, and a GOES 16. I'm not too sure which light this is, but you can see the moon shadow going from lower left to upper right. And you can see the cloud movement at the same time here. Next one. Okay, and then this is a composite again. This is what they call a time composite. The process that they use to get this gets you a lot more precise indication of the path of totality by putting together a series of pictures. I think this one was a series of 100. This is either 20. Let's see, I don't think I put it on here, but I think this is a series of like 20 to 100 of the GOES satellite pictures. Okay, Gary. Oh, that was 21. I'm sorry. That was up there. Okay, this one coming up is from the LRO, the Lunar Reconnaissance Orbiter, in orbit around the moon. NASA has had this satellite in orbit around the moon for quite a few years now. Has a very, very precise set of optics on board. And as you can see in the next picture, you get a very nice, clear view of the Earth at the time of totality. In this picture, I think that if I'm not mistaken, this was on the path where I think it was Point Gerardo, Missouri is located at the time. The little yellow dot that I have off to the left of that shadow is Los Angeles or Claremont, where we're standing right now. But you can see that, even though it's from the distance of the moon, you can see pretty clearly North America along with the shadow of the moon. Next one, we're going out to 930,000 miles from the Earth. This one is located at the L1 vibration point in the Earth-Moon system. This one is a picture that was taken by what they call the Discover satellite. Let's go to that. And this is a series of pictures that have been put together. What's nice about this is it's in color. And you can clearly see the brown land masses along with the white clouds, along with the shadow of the moon. I thought this was a kind of a neat depiction of the solar eclipse. Okay, next one. Okay, now we're going to part 3. This is my own, I guess, my own voyage to Wapakoneta. Wapakoneta is the hometown of Neil Armstrong. It's located in west central Ohio. And I didn't go there specifically just for the eclipse, but as it turned out, the other reason I went there was happening the day before the eclipse, and I got to have 2 consecutive good days of weather. But I'll show you a little bit more about the weather here coming up. Okay, so this is a summary of the eclipse. As it shows here, the duration of totality there was 3 minutes, 57 seconds. And if you look at the very bottom of the figure here, it says this day was cloudy 67% of the time since 2000. So based on the GOES satellite weather data that NOAA has put together for Wapakoneta, I figured that the chance of having a good day to see the eclipse was going to be about 30%. And to have 2 consecutive days with good weather with no clouds was only about a 9% probability. So I really lucked out. Yeah, Gary. When I say luck out, I'll show you what actually transpired. This is the actual weather data for Wapakoneta. It starts on the extreme left on Tuesday, April the 2nd. That's the day that I landed at Dayton, Ohio. On that, right before we landed, they had a big rainstorm in Dayton. And on the way up to Wapakoneta on Interstate 75, off to the right-hand side of the car was a nice big rainbow. I took that to be a good omen. Turns out the next day, Wednesday, April the 3rd, it rained again. It doesn't show it in the weather report for that day, but it was a very localized shower. We have to be sitting at a Subway eating our dinner, and we had this downpour. And after, as we were having all this rain come down, we looked across the road where the Neil Armstrong Air and Space Museum was located. And there's a nice rainbow with the museum centered right in there. And I thought that was another great omen for a good day coming up for the eclipse. But as you can see, we had a lot of cloud coverage, April the 2nd, 3rd, 4th, 5th. And finally, on Saturday, April the 6th, we had some nice sunny day or sunny skies. Same thing on Sunday, temperature was increasing. The squiggly line there is the temperature. One thing that I thought was kind of interesting is on Friday, April the 5th, when the sun started to come out just a little bit, I actually found or saw some snowflakes come down. And that's only because if you look at the winds were coming from the north, which is from Michigan, and Ron can tell you all about cold weather in Michigan. So anyway, we had not only rain, we had a little bit of snow, but finally on Monday, we had nothing but clear blue, sunny skies. And I thought that was just outstanding. This is a depiction of two different eclipses. The diagonal line that goes from the left-hand margin off to the right is the actual southern boundary of the total eclipse of 1806. The reason I show this is that was the previous total solar eclipse in Wapakoneta, and that was called Tecumseh's eclipse. As you can see, Wapakoneta, which is just above in the shaded area, was actually in the shadow of the moon. So people at that time who were there could see the moon actually being eclipsed. The other diagonal line is the center line of the eclipse on April the 8th. And as you can see, that center line actually goes just south of Wapak, and it is also just south of St. John's. What's interesting about that is that Tecumseh's rival, Chief Blackhoof, is buried right there at St. John's. And I have called this eclipse on April the 8th, not Tecumseh's eclipse, but Blackhoof's eclipse because of it. Okay, next one. Okay, this is a view of the Neil Armstrong Airport at geez. Hang on. Isn't that weird? This is just south of Wapakoneta, New Knoxville. I didn't even think of it. If you look in the back, New Knoxville is off here to the west. The airport is just south of the road right there. They had about 100 planes come in for the eclipse. So, you know, you might think that 100 planes is nothing, but for that little town, that's a big deal. We have next one. And this is an aerial view of the Armstrong Air and Space Museum on the eastern boundary of Wapak. they had about 4,500 people who attended there. And that was probably the most densely populated area of the town during the eclipse. I avoided that area. I did not see the eclipse from there, but that's where most of the people were. This is a ground view of the personnel that were at that location. What I want to point out in this photograph is that even though we had nice, clear, sunny skies, we did have clouds, but they're not natural clouds. For some reason, they had all kinds of contrails from jets. So what you see crossing over that look like clouds are basically contrails from jets. Okay, go ahead, Gary. Okay, and this is a picture that was actually taken of the eclipse sun from the Armstrong Air and Space Museum. And as has been pointed out before, looking at the 6 o'clock position, you can see the solar prominence that was very apparent to the naked eye as we viewed it there in town. Next one. And this is another picture that shows the prominence, which is a reddish hued projection from the sun at about the 6 o'clock position. But you can also see other prominences around the moon there, along with Bailey's bead. This is a closer up picture. As Matt was pointing out, that prominence dwarfed the size of the Earth. If you look at the picture just to the right of the major prominence, there is a depiction of about the size of the Earth. And you can see that the Earth is not all that big compared to the prominence. Next one. And this is a closer view of the prominence along with Bailey's beads. And this one was taken from Franklin, Indiana. Next one. There's another picture, somewhat the same type of depiction of the prominences. And then this one here shows the Earth just to the same scale as the prominence there. This is the biggest close-up picture of the prominence I was able to find on the internet. It's a very nice picture, but this one here, this picture, I think is fantastic because there are 2 objects that were captured in this picture that most people were not able to get. And those are 2 comets. Before the eclipse, I think a lot of the astronomers, knew that there was going to possibly be an opportunity to see Comet 12P. However, as it turns out, the same day of the eclipse, another comet was discovered, and it's called Comet SOHO 5008. Comet SOHO 5008 was discovered, it was named, it was photographed, and it was destroyed when it grazed the sun all within 24 hours. That might be a record, I'm not too sure. And this is my final photograph. This is another picture I saw on the net. It's a nice, long duration photograph of the solar eclipse in totality. And this one also shows 5,000, what was it, 5008P comet. So what I think is really neat about this one is that not only can you see the comet, you can see all the stars around the sun at the same time too. I thought this is a pretty nice picture. It's sort of comparable to the one that Ron had shown. So that's it.